Well, we're back in the lab with another piece of boxed test gear. In this case, there isn't really any indication of what it is. It does say suspended, calibrate before using, Hanford Engineering Development Laboratory, and has a part number. It comes from Hanford. I'm going to assume it's not hot, radioactive. Nothing on the bottom. It's just a metal box. It's got a card here with instructions. Instrumenter test, copper leads, instructions for using the Brown portable potentiometer model 1117. Fair amount of instructions here. Check a millivoltmeter to check one thermocouple against another. So again, it's some kind of a rig to compare items against each other. See if I can get the whole thing in frame somewhat. We've got some large binding posts. Additional momentary standardizing rheostat. And down here along the bottom it says renew battery. And in the instructions, when you have to crank this around into the renew battery space, that tells you need a new battery. What sounds like a pretty large rheostat. Look, it goes to 11. That's actually really cool. Get that volume way up there. It's got a millivolt scale here. It's labeled 0, 10, 20, 30, 40, 50, and 60. There's a calibration sticker here, specs unknown, assigned to plus or minus 0.1%, 62481, and 62482 is when it expired, so it is, of course, well out of calibration, as we always do. Let's take a peek inside, see what we've got. This always assumes I can get the screws to back out. Won't be too long, I'll have run out of these instruments to tear down, and I will have to go looking for another batch. Most of these I've gotten for a few dollars or free, which is of course always preferable. A couple of them are nice enough that I've actually displayed them at times. You know, just a black box like this, as compelling as the front panel on it is. Really displays all that well. Oh, interesting. There's something useful. Down in the bottom of the case here is a little voltage standard. I haven't seen one of these for a long time. A little 2-cell voltage standard. Standard cell number, dated December 12th, 86, installed 22764. Obviously the battery compartment's over here. This is going to be a little bit difficult to deal with this large hunk of cable hanging out of it. I'll see if I can figure out a way to get it into frame where you can actually get a view. Looks like that's on camera. So there's that very large rheostat. It's got to be 6 inches across, maybe a bit more. It's got a wiper over here. It looks like that's the pickup to me. Yep. Or is it? Any other brushes? That's just a mounting. There's the dial. Oh, I see how it works. Okay. So I see what's going on here. There's two metal bands. There's a solid one here, and there's a wound spring type one here. And I don't know if I can get this into frame. There's a little contact here that's got a fair amount of pressure up against it, and it's essentially making contact across in position. So the resistance varies here, and it's just a pickup to return it here. So both sides of the resistive winding, and then down here we come through to this solid piece. So that's interesting. That may be the largest potentiometer I've ever seen. I suspect it's very accurate. We have another rotary switch here, very similar to the ones in the instrument I did the teardown and repair on recently. I can see in here again they're wire wound resistors. In this case, it's got a center pickup and what, 1, 2, 3, 4, 5, 6, 7 positions. There's of course these beautiful knife switches in here. Well, they're not knife switches, but very old school. I don't know if you're getting a view into the mechanism there or not. Another nice wire wound transformer. I don't honestly know what these 4 cylinders are here. What I'm assuming is the galvanometer. It's the little meter movement that you tune to a display, you know, delta from the center 0. Don't know that there's a whole lot more to see. I'll get some high-res photos of this. I've got to get back on my blog site and start posting high-res photos. One of the viewers asked for them, and it's something I should be doing. I have to say that is by far the largest potentiometer I think I've ever seen. I bet you can get some very accurate resistances positionally from it. Let me see if I can manage to finagle this around. We can actually get to where you don't want to touch. I've got my ragdoll. So, a couple of assumptions: that it doesn't have a battery in it, doesn't weigh enough, the metal case. That little standard cell probably isn't outputting any voltage. I want to actually take a look at meter leads are well zeroed. Let's see if I can get in here. So there's the center wiper, it looks like. And the white one coming up looks to be one side of the potentiometer. Oh wow. Let's zero it. So that's 0.03 approximately ohms. I must not be across the wiper. That's measuring very consistent. I've got a white, red, and black, and the red looks to be coming up from the center conductor. And what's the total resistance of the resistive element? Of course, this assumes I can actually get the leads in here and get contact. It is 3.70 ohms. Wow. 3.70 ohms. I'm pretty sure I can't get in there and clip on down internally there. Oh, I did. So 3.9 ohms, 3.8, 3.7. Wow. 3.9, 4 ohms. So that's interesting. I thought end to end I measured 3.7 ohms. It's not being affected by rotation. There's the 3.7, 3.8. It is increasing, so I'm a little confused here by what I'm seeing, why I didn't see the full resistance. Wow. 4.300. I was able to actually, just with my finger, get it to 4.300. 4.310. Wow, that's an amazing, amazing potentiometer. I've got the same question again. Why? The red and black. The white and black do come up to here. I should be able to clip on here and here and actually look back through the resistance. 3.9. There it is. I just had a bad connection before. So let's take it around to full rotation. Zero 0.037, 0.2, 3.4, 0.6, 0.9, 2 ohms, 3 ohms, 3.6, 4.2, 5.1, actually 5.0. I've got to let it settle down after I move it. And then it starts to come down again. 4.7, 4.6, 4.5. I find that really odd. It might be looking back through the circuit. It might be being influenced by that little voltage cell. Now that's quite interesting. I'm going to set various parts of this aside if I can. And see if we can get a look in there at that little cell. I don't know if it's showing up on camera. It is. I used to have a couple of these. They are long lost. I believe technically you're not supposed to do this, measure them directly, but I'm going to just briefly get the probes plugged in. I expect it to be slightly over, if I remember right, 1 volt, though I don't. It's been a long time. We're on volts DC. Go ahead and null that. And of course the voltage is shifting. I don't know if it needs to be lying flat. It may need to lie flat to operate so that the acid or whatever the electrolyte in there is in the proper orientation. There's a reason it's sitting in the case in the orientation it is. Yeah, 1.018 volt. That's in that range of what I remember it's supposed to be. 1.018 for 4443, so 1.0184647 volts. That's actually a nice little find. Let me remove that and mount it in a small case just to use as a high precision voltage standard. Nice little find. Figure out the orientation that it goes back in. Ooh, sorry about bumping the camera. I didn't pay that much attention when I took it out. It's either got to be oh, I twisted the cable or the wiring loom probably. It has to go this way, otherwise the galvanometer wouldn't clear the battery compartment. It must go in this way first. Oh, that's nice and tricky to get back in there. Twisting that will help bring it down out of the way. Should have paid more attention when I took it apart. That wiring loom is very stiff. It is hitting on something. I just don't know what. There we go. Back down in place. Actually, I'm going to shoot some high-res photos inside, so I won't put the screws back in. But anyhow, there's a quick look. Hopefully it was entertaining. Talk to you later.